LeetCode problem number 2144, minimum cost of buying candies with discount. A shop is running a promotion where for every 2 candies you buy, you get a third candy for free. The catch is that the free candy must cost less than or equal to the cheaper of the 2 candies you purchased. You are given an array of integers cost, where cost.I is the price of the ith candy. You need to buy every candy in the array, and you want to spend as little money as possible. Return that minimum total cost. For example, given cost equals 6, 5, 7, 9, 2, 2, the expected output is 23. The naive idea is to try every possible way to group the candies into triples and pairs and singles, paying for 2 candies in each triple and getting the cheapest one free. We could enumerate every subset of size 3, mark those as a group, recurse on the rest, and keep track of the minimum total cost across all groupings. This explores an exponential number of arrangements, so it quickly becomes infeasible even though the array is small. The complexity here is O(n) time O(n) space. The key insight is a simple greedy. Sort the candies in decreasing order of cost. Then walk through the sorted array 3 at a time. Inside each group of 3, we pay for the first 2, which are the 2 most expensive, and take the third one, which is the cheapest of the group, for free. Any leftover candies at the end of the array, 1 or 2 of them, we just pay for. This works because pairing the largest unpaid candy with the next largest lets us always discount the biggest possible candy that the rule allows. Concretely, we sum every cost whose sorted index is not 2 more than a multiple of 3. Sorting dominates, so the algorithm runs in n log n time. The complexity here is O(n) log n time O(1) space. Now let's implement the optimal solution in C++. I'll write it out step by step so you can follow along.